This is the Commander. Are you listening?
Welcome. I am the real Commander, Stephen Gill, owner, CEO, gillsystems.net. Check it out. Anyways, we're here today to talk about the Commander OS, a multi-agent, all local, currently AMD LLM setup, multi-agentic, multi-nodes. We have it running on my main system, Gill Systems main, which has the 7900 XTX and 48 gigabytes system RAM. You're going to be able to see all of these systems in real life as well as remotely. We're using Rustdesk to remote into all systems. So the nodes include Gill Systems main, that's this one, with the 7900 XTX. As you can see here, we're going to start out very low RAM utilization, GPU utilization, and power is going to be here. I think that's an AMD bug, but that's another story. Anyways, that's the main system. That's the brains. We'll talk about models and stuff afterwards. HTPC. This, as you can see, let me go full screen. This is Kubuntu. I do not like GNOME. It is terrible. So we went with the KDE. Here we are. Okay, total system setup. Core control over here gives us the same effect. Let's us see. As you can see, the 7600 is running at 5 watts, and we're at a slightly over 1 gigabyte. This is the 7600, as you can see, regular. Okay, so that's the second node. This particular node also acts as the relay between all of them and the persistence storage. This Ubuntu is total ZFS. The pools are total ZFS. And we even added a second SMB drive that's also going to be, well, it is ZFS. ZFS is awesome. We can resize our pools as we want. We can add to it. We can do basically whatever we want. All right, so here's the executable for that. We'll get into that in a moment. And finally, for the nodes outside of the laptop is a node. We have a Steam Deck, and we're going to see all of these. Actually, let's go and do that. I probably should have showed you. That's the main system. 3 monitors. There's the actual computer with the actual 7900 XTX. Keep in mind, gloves nice and dry. That is HTPC right there. And as you can see, we're remoting directly into the Steam Deck. And just so you can absolutely see it. Alright, and we're going to be needing to go to here, and we're going to set them up in order. The last node, of course, is the laptop that we're recording on, as well as it was mostly written on this laptop, 4500U. Here's the info on that one. Yeah, here it is. This is my workhorse. Yeah, this has got 20 gigs, as you can see. We're sitting at about 7. Once we get all the models running, you're going to see that it's actually really interesting. It just totally eats up the RAM everywhere. I've done a couple reboots throughout the day during testing, but it's at a spot now where we wanted to just show it going. Okay, now the order in which we boot these off is we're going to go with the HTPC first, because again, this acts as the storage relay. And I'm a one-click guy, so we got the script for the Linux nodes, which work on both the Steam Deck and the HTPC. But we're going to set off the Windows one, which is Windows 11 here. We showed you that with the 7900. All right. One of the things that we have is the models are stored locally. The storage is also stored locally. We don't have to run this as admin, so we'll just do a regular. You're going to see 3 command windows. there's the second one. This is the actual engine. This is the actual model. This is the big one. You're going to see right off the bat it changed the RAM. Oh, maybe not. Maybe we're going to have to actually use it. Or maybe I used a smaller model. We'll see. Anyways, okay, so this should be good. So HTPC is up and running. Node 801. 8001, sorry. 8000 for Gill Systems main. And let's not forget our little buddy, the Steam Deck. Alright, so yeah, architecture-wise, we go all the way from Vega, running on Vulkan, to RDNA 2, which is what we're going to see on the Steam Deck right here. There it is, with our node 8003. And then the 7600 is RDNA 3, obviously, as is the 7900 XTX. All right, let's check the, all right, so RAM out of the possible 8 on that is at 5400. Steam Deck, I actually did open up a system monitor just to check it out. It's not really being used. Total memory is about half. All right, okay, all right, so everything's good. Now let's get our laptop running. There it is. And then we'll open up the GUI. So this is what it looks like. Let's do a quick refresh before it hits, just so it's already there. Perfect. We got our branding here. Oh no! Let's do it again. 9,000. All right, yeah, we're fine. Yeah, we're fine. I'm going to ignite all and make sure they're all good. Okay, welcome to the Commander OS. Alright, let's do a new chat. Okay, so you can see the model we chose here. This section, this node, whoever you're chatting with, what it's going to do is it's going to rank the intelligence nodes right here to whatever is the smartest. Okay, so we got laptop. And I do have some benches from the initial testing here that kind of like gave it where it should work itself off of determining who's the smartest or not. HTPC, we could actually jack that. That's about right though on main. And so here's all our nodes. Right now, we're going to get some of this to work a little bit better down there. But let's go and we'll change the model. So we can actually change the model. And this one, you see, I put my ranking on the initial testing right there, and then what the actual model is. So right now we're using 5.4 reasoning plus. I use all GGUFs in it, all of them. Okay, which is probably a good spot to tell you where the storage is too. So storage is usually going to be stored right out on your local drive. So we want those in all of your local drives, as well as there's going to be a scratch pad. So you see mine's right on my desktop right here. And so here's the available models that I have on this node. This is just the laptop. So that's going to be part of the, well, it is part of the README and the documentation of trying to be smart on what you're loading for whatever your node is. You know, do you know if you have enough power for that particular node? So let's give it something now just to see if it's actually there and ready. So are you there, Commander? There. Okay, cool. And there it is. All right, so it knows who's there, what they're doing, and what you're going to be able to do with it. Now, part of what we had to fix in the bugs was resizing, all that sort of stuff. But let's give it a different model, and we'll actually be jumping over remotely to see that actual model in work. All right, so you can see on each node control, we're on main. Here we are. I do have to fix this. It was giving garbage before, like faking it, and I'm like, dude, no, No. All right. So, anyways, let's go. Let's save the context size of 50K. I'm going to also leave that there. Flash attention. We're also going to leave on. This was a good thing. A lot of my fixes came through of trying to make my things easier. So initially, when I was doing local servers up here, you can see them all. I would rename Llama server to Go, and then of course you'd switch your ports and do all the fun stuff that you wanted to. When trying to design this and go with reproducible, I realized I wanted it to be agnostic, so it is binary agnostic. You can use llama.cpp, you can use Ollama, you can use VLLM, whatever you want. So what we're going to do is we're just going to pick our drive here. It's going to do a quick little scan, and then we're going to say, okay, no, oh, what's going on? Oh no, I hope that's not broken. That was working. Select the drive. All right, so that was working. Oh, new bug. And then yeah, so it's now even saying that it's offline. So I don't know why it's doing that. Which means it's also reporting it incorrectly. So let's do a reset. Local storage info. Yeah, but if it's not catching the right path, great. Anyway, so this works here. That needs some work. And the model should be the same from the one we were using. Let's see if it actually found. It doesn't look like it did. Alright, so yeah, we're gonna have to work on that. But yeah, so this is the commander. I hope you liked it. We're gonna still be working on it, but it's working. It is certainly working.